Welcome to this lecture. Yay! I'll try and is it recording? I don't know. Is it recording? Let's have a look. I'm now recording it. Yes, I'm checking this. I'm watching itself record itself to see if it's recording itself. Yeah, that's about right. Okay, so now that's all good. So back to the plot. Right, fine. I've done this before and discovered that there's nothing on the tape. Right, so this is XNA and MonoGame. If you want to get started on the development of this stuff, then these are the steps you follow. Get hold of Visual Studio 2013, install XNA 4. There's the xna.coplace.com. There's a really weird comment on there where it says something like, we're providing support for XNA until Microsoft does, which makes you think, ooh, maybe it's coming back. I have a horrible feeling it isn't, but XNA is just awesome, so you should sort of think about it. You'll need XNA 4 because it's got some bits and pieces that XNA and MonoGame need to work together with. And this is particularly in relation to content management, of which I'll talk a bit at the very, very end. Although the MonoGame guys are doing a talk in this very theatre at 5:15 on Friday, which you must come to, dressed as a zombie if you like, or not. I'm not really bothered either way. No, probably couldn't tell. And they'll be talking about content management there as well. But install that. Then go get MonoGame. I'm using version 3.2, the most recent release, the most recent proper release. And once you've done that, you can make games that you can release onto your PC and also in Windows Store. And you could port to Android and other platforms should you wish to do that. Android, iOS are all viable targets for MonoGame. That's why I love it so much. So the games that you write can be ported across all those platforms. And during this talk, I'll show you the things to bear in mind with regard to making the games portable, because what you'll want to do is make sure it works on an iPad, an iPhone, a Nexus 7, a Windows Phone 1520, blah, blah, blah. And the way you do that is by managing the size of your assets in such a way as you can scale them really easily when the system figures out what it's running on, of which more a little bit later. But basically you get these new project types, and you can go from Windows Phone 8, Windows Store, XNA, blah, 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 or you can make one of those and play with it. But what I'd advise you to do is to start from my Cracker Chase program, because that is guaranteed to work, mostly. Okay? So you can take that and play with it, and it basically implements what you could describe as a complete game. So now I'm going to start up Visual Studio. And we'll take a look at what Cracker Chase actually does for us. It's not, it must be admitted, it's not a particularly advanced game. I'm hoping this is the right one, otherwise it might not even compile. Let's just see if this works, shall we? Boink. Bang. Okay, so the game of Cracker Chase is very simple. I am a piece of cheese, and my job is to chase crackers and eat them. So I press space to begin the game. I start chasing cheese, and it works each time I find one, and I've got 5, 4, 3, 2, whoa, we've got this, and then the game over after 10 seconds and I've scored 40, which is not great. Okay, please don't make every single game that's shown off on Saturday. You sort of got Ghoul Chase and Chicken Chase and whatever chase. Please don't make every single game a chase game, because although you can do that, it's not going to really impress the judges very much. All I want to show you in this game is exactly how the gameplay fits together, and how you can take what I've done and modify it to make the games that you want to create. I'm particularly concerned with making games that manage these guys, the sprites on the screen, and control how they interact. I'm also interested, let's just play again, see if I can improve on that. Okay, let's go to this one, and then that one there. Oh, no! And then that one there. And this is probably a bit boring, actually. Oh, yeah, better do it. Better score that, 50. So, having totally failed to wow you with Cracker Chase, I'll actually move back to the program, stop it for now, and then we'll go back to the slide deck. It's not a very good game, but as we'll see, by making a few changes, you can make it much more interesting and start moving off in all kinds of neat directions. So don't be put off by the fact it's a bit simple. It's because that's my starting point. This is what I want you to understand how it works. If you look at a game, XNA, every game you ever buy works like this. Okay? I thought when the PlayStation 4 and Xbox One came along and we had high performance DVDs and Blu-ray drives and stuff, we'd have no loading screens ever. This does not seem to be the case. Every game that you ever get seems to have loading screens on it. And so the game starts, it initializes all the resources, fetches the textures, the models, the scripts, the sound effects, blah, blah, blah. Once you've got your loading screen out of the way, the game then does two things as fast as it can. It updates the game world, it reads the controllers, updates the state and position of all the objects in the game, and it draws it. And the aim of the game is to do this as quickly as possible. They run these two things independently because the speed at which you draw the game world is allowed to vary. I used to play Need for Speed Most Wanted, the first version, Xbox 360, and you're driving around the open countryside and it's amazing. You go into a city and the frame rate disappears. It goes chug, 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 chug as you're panning as the frame rate. You must have seen this. Suddenly the screen gets complicated and the frame rate goes through the floor because the renderer now has more work to do. It's okay-ish for that to happen. It's not okay if the game world slows down. Because if that slows down, bullets start going through things, you start missing the fact you've hit the ball, and the speed of things in the air and whatnot starts to misbehave. So this guy's not allowed to vary in speed. This guy, any spare time we've got, will render it again, because the faster we render it, the better it will look. That make sense? So these are the three fundamental behaviors. What XNA does is it maps a method in a class to each of those three behaviors. If you're a first year, you know that everything happens when you call the main method. That's main method, my program starts to run. In XNA, it's a bit weirder than that, in that what happens is that the system calls the methods for you, a bit like main being called, but rather than being called once, update's called 60 times a second. Draw is called at least 60 times a second. So that means that you just fill those methods in, and then the XNA game will call them for you. The game starts up, we call initialize. The game starts running, we call update and draw. If you were at the Arduino talk a couple of weeks ago, that has a setup and a loop. They are very similar in terms of how they work. Okay? But the idea is that what we do to make our game, we figure out what textures and models and scripts that we need. We put those into load content and set up all our game objects. And then once we've done that, we populate the update and the draw methods. The update method reads the keyboard and moves the cheese around and checks for collisions with crackers. And the draw method takes all my objects and puts them on the screen. Does that make sense? That's all there is to game. This is how games are. This is how all games are. This is how Need for Speed Most Wanted, Mortal Kombat, blah, blah, blah. They're all like this. This is how they all work. Maybe Scrabble isn't quite like this, but then again, maybe it is. I don't know. Think about that one. That's a good one to think about. So, I'm going to look at Cracker Chase. Because Cracker Chase does these things. It fetches the content, it does the update, it does the draw. And what I want you to do at the end of this talk is have a really good understanding of what it is that Cracker Chase does with the objects it's got and how they work. Because a really good way forward to make a game is to take Cracker Chase and just pull it to pieces, and we could give probably a big prize to the best customization of Cracker Chase, the best non-Cracker Chase game, which is submitted. That would be quite interesting. Before we do that, quick word about sprites. This is actually not Sprite, this is a different drink. Jokes with props. That's going to work on the recording really well. A sprite is a game object, and it has a position, whereabouts on the screen we draw the cheese, and a texture, which is the cheese. If you're preparing game assets and you're drawing pictures, please don't use JPEG. Why is JPEG a bad idea?
White space.
Pardon? White space. You have to go
transparent.
No transparency. Better way of putting it. My cheese is a perfectly designed. I actually bought that cheese, photographed it, and ate it. It worked really well, and then I wrote it off against tax. Yes. The cheese is actually in a rectangle. It's a rectangular bitmap. but some parts of it have been made transparent. When I edited it, I just cut out the background, and that's my cheese. If you want to use transparency, then you want to use PNG images, I would suspect. JPEGs are great for the background because they're small and they haven't got transparency, but for the foreground objects, use PNG. Have you heard of Paint.net? It's a really good freeware program with just layers and all kinds of good stuff. Paint.net's a good tool to use to make your assets. So is Photoshop. What do they use in the jungle to make all their pictures? Do you know? They use Photoshop elephants. Okay, fine, right. That's better. Is that better than the other one or worse? I don't know. Better. Okay, I quite like that. Yes. Okay. There's a program called Photoshop Elements. If that ruins the joke, then I can live with that. Okay, so we make sprites. If you take a look in my program, a sprite is a class which has a whole bunch of data payload. It's got how big the screen is, so it knows when to bounce or to stop moving. It's got a texture which tells me what the sprite looks like. A rectangle that says where on the screen the sprite is going to be the size of it. It has an X and a Y position, which is where I'm going to draw it. And it also has these two guys, X reset position and Y reset position. I have a habit now of slapping those in my game design right at the start. And the reason why I do this is because I'm thinking a little bit ahead. When we hit game over, players finish playing the game, they've got the score, and they press, I want to restart the game. You don't want to have to remake all your objects because that's really slow. You could throw them all away and make brand new ones. I guess you can see how you could do that. But it makes much more sense to actually just put them back to where they should be on the screen to restart the game. So these two values here are set when I construct my sprite. And they say, OK, when I ask you to reset, that's where you go back to. Does that make sense? So what I'm doing is I'm thinking, and from a game design point of view, carry this away. Think in terms of how you will manage the entire game life cycle, not just playing the game. And so then that means when the item has to reset, I put the player back in the middle. You saw the cheese goes back in the middle each time I start the game. And so I've told the system, the cheese sprite, when I reset it, I've placed it in the middle of the screen. Does that make sense? So those are the things. This is kind of like the minimum payload of the simplest sprite. Where it is on the screen, what I draw, a bounding rectangle, and you have a question.
What's protected?
What's protected? Anyone know? Technically, yes. We haven't, you're a first year. We haven't done class hierarchies yet, but we will do. I've got sprites based on the sprite class. I've got one that moves, and one that's a target, and one that moves with physics, okay? They're all children of this guy. What protected means is the children can see these things. So inside my mover sprite, I can get hold of this stuff. But objects outside this class, not in the sprite hierarchy, can't see those. So it's a way of halfway. I'm not that big on protected, but it's there. It's okay. You could make in a game. We're not talking bank accounts. We don't really mind if someone fiddles with our game elements. It's not really a high security application, but I still try and make things vaguely secure because it's sort of I'm built that way. I'm not a Python programmer. I'm a proper programmer who plays with Python because everyone does. And now I'm going to move on to what I'm going to take. So that's the standard sprite. That's whereabouts on the screen it is. So we know when to bounce. That's the texture. XNA has these special types. In C# you write programs use strings, floating points, integers, blah, blah, blah. XNA provides a thing called texture, which is basically a 2D graphical texture, and also rectangle, which is a thing that has width, height, and position. And this guy's interesting because this is how we control the draw process. When we draw it, we'll say, draw this texture in this rectangle on the screen, please. So we have to have both those. And then this, I'm not particularly happy with it, but it works really well. These guys are the X and Y position of my sprite. Now they could live in the rectangle, but Mr. Rectangle is only ever concerned with integers. So he can, width and the height, integers is fine. Position, not so good. So I'm kind of duplicating information by sort of position twice, once in here and once in there, but we'll sort out how I deal with that a little bit later. So that's where the sprite is, and that's where it gets put. So I keep going. That's where it is. and that's where it gets put on the screen. I use floating point for these because occasionally you want objects that move very slowly. And if you position them on integer bounds, you can't do that. You see here, I could add 0.1 of a pixel every second, and I could have this thing actually move very slowly across the screen. If it's an integer, I've got no chance. So I use float for these guys, rectangles and what have you. Does that all make sense? Okay, so we've got that in the sprite. That's lovely. When I come to make a sprite, I construct it. I go off into the content management system and load my tablecloth texture, which is the blue and yellow, which actually was a tablecloth, amazingly. Not a particularly tasteful one, but it was a tablecloth. Having done that, I call my constructor. I say, OK, screen width, screen height. There's my cloth texture. I want it to be as wide as the screen, please, because that's how wide it's going to have to be. And I want it to be positioned at 0, 0 when the game resets, because that kind of makes sense too. So I've gone off into the system, and I've got some variables I've set that tell me how wide the screen is and how high it is. Now this goes back to my concerns about compatibility, in that I have a worry that if we change the device I run my program on, I still want the screen to look right. So if you look inside the Cracker Chase game, you'll find there's a piece of code, I'll show you in a minute or two, that actually goes off and says to the graphics adapter, OK, how big is this screen? And it comes back and tells me, and I use those numbers, and I pass it the width, and the construction of the sprite scales it so it's that wide. It also takes account of the fact it might not be square, and sorts out what's called the aspect ratio, so we get a thing that looks OK on the screen. Okay? So the idea here is that that's me, that's my sprite, that's the simplest sprite, and that's the big one, and I hand at the back. Yes?
Is 0, 0 the center of the screen or all the corners?
That's a fantastic question. The question is 0, 0 the center of the screen? The answer is no. In computer graphics land, for some reason, 0, 0 is always the top left-hand corner. So I'm placing my... Yes, you can use... You can say that if you like, but yes, it is. That's how it is with XNA and most games as well, and I apologise for that, but that's the way it is. Sorry. XNA, top left, is 0, 0. So if I want to move things down, I have to make the Y coordinate decrease to move them. No, increase. Moving things down the screen, Y gets bigger, lesser, different. I'm overthinking this, Rob. If that's 0, 0, and I want to go down, I'm going to have to make Y
Bigger. Bigger.
bigger. What's that?
Yes, it's bigger.
It's just like Bruce Forsyth, play your cards right. It's not the way you would expect. If I increase Y, it goes down the screen. If I decrease Y, it goes up. So you make Y bigger to go down. It's annoying, but that's the way it goes. You see my code, you'll see I've got a plus and a minus in the wrong way round for that particular behaviour. So 0, 0 to my top left-hand corner. It turns out that actually positioning things by their top left-hand corner is not always optimal. When you start rotating them, really weird things start to happen. But as far as we're concerned, keeping it simple in XNA land, this is how it works. I've got some bits and pieces in my code that will hide this nastiness from you, and we'll come to those in a minute. Is everyone okay so far? Okay, keep nodding. That's jolly good. So, a background sprite. Now, we've just discovered in 08101 the wonders of lists. Here's a fantastic example of a list being used to very good effect. I want to treat all the things on my screen as just different sprites, and so I make a list of them. So in my game at the top, I have a thing called game sprites that contains all the sprites on the screen, and when I make my background sprite, just after I've made it, I add it to that list. So that when I come to do my update and my draw behaviors, I just spin through this list and say to each sprite, hey, update yourself, or hey, draw yourself, and the sprites look after it. Does that kind of make sense? So in terms of level design, you may well have a list of sprites for each level. And so you'll flip between the list depending on your level 1 or level 2 or level 3. Does that make sense? So first level could have chickens, second level could have spiders, third level could have, I don't know what, depending on your 3 words. And you would have different lists of sprites, and you go through those and display them depending on what you're actually doing. So, sprite's fine, but it's a bit dumb. It can't do much. Target is a new kind of sprite I invented based on the old one but this guy has the ability to place itself randomly on the screen. So I would say to Mr. Target, hey, place yourself randomly, bang, and it moves itself around. Okay? And I set it up just the same way. Width of the screen, height of the screen, the texture for the cracker, how wide the cracker wants to be. Put it at 0, 0 to start with if you like. It'll get moved very soon after it's been created. And then off we go. So, and I add that to my list of sprites, of course, because although it's a target, it's a child of the sprite class, so I can treat it as a sprite if I want to. Second years, we'll be doing class hierarchies next semester. They are wonderful. They'll let you make objects based on other objects. So if you think about it, a target is just a sprite that has to be able to place itself randomly on the screen. And so I make myself a class which is based on sprite, just adds that behavior. I can show you. You want to see it?
Yeah.
Okay. Lack of trust on your part, that's okay. If I go into my sprites class, there's my sprite. Say hello to Mr. Sprite. I'll give it a bit of room to breathe. Don't actually say hello because it can't hear you and it doesn't care. So there's my sprite, exactly what I told you. There's my constructor, which takes all the values in from the sprite and sets the guy up. There's all kinds of things that sprites can do. The mover is one of the kind of sprite. Physics mover, we'll come to, he's kind of funky. Target is tiny because target is just like sprite, except for the fact it contains a random number generator and a method called random place. And so I can say to a target, hey, place yourself on the screen somewhere, please, using my random numbers. And so it says, okay, I'll get the next random number in the range that works for the sprite size, and I'll put the sprite there. So my sprite has a method called set position, which will do that for me. And the rest of it is just constructing the target. So my target sprite is tiny, because all I've had to do is add a little bit of extra pieces I need to make it behave like a target. Does that make sense? Okay, so we're okay with that. That's all good. And so we got that. This is the target sprite. That's all wonderful. Again, because I'm clever and I'm concerned about portability, I work out the width of my cracker based on the screen size. So I'm going to say, okay, a cracker is a 20th the width of the screen. So whatever device you play it on, that's exactly what size it'll be. So it'll look right on everything. Okay. Mover. Well, mover is a sprite that can move. Not surprised. This is the cheese. The cheese we have to move around the screen. So what we do is we make a new kind of sprite based on the old one, but we add 2 extra parameters to the constructor, which are the 2 500 and 500 at the end. These tell me how fast the sprite can move in pixels per second. Sounds quite cool. So 500 pixels per second seems to be about right. One of the things that I would strongly recommend you do when you're doing 3-thing game is have somebody on the team responsible for fiddling with the game and playing with it a bit, or make sure that you've got a spare machine somewhere or something set up with the game on it you to play with, because these numbers here, there's no way you can mathematically predict those. You can at some point in the game you get to the point where you just put numbers in to see what happens. Yep.
But if the screen resolution is lower and there are less pixels, will it move faster along the screen?
Curse you. You're completely correct. Can I fix that? Meh. Yes, you made a very, very good point. There's me going on and being all clever about things. What that means is if the screen's smaller, this thing will go a lot faster on a small screen. Correct. How do I fix that?
Half the speed is a fraction of the screen width and height.
Yes. If I, rather than saying 500, I say half the screen width per second, I'm golden. Does that make sense? So the good news is that I could actually survive that. That's a really good question and a very nice point, and thank you very much. But there are no prizes, I'm afraid, so you've won nothing. Any other questions on that? So I've got a thing called mover, which moves around, and I've got a thing called target, which I can chase. I've got a thing called sprite, which just does simple stuff. So we're all okay with our game objects. So if you're thinking in terms of your game having a blah, a blah, and a blah, then you now know how to sort of put those on the screen. Is that all right? Now we have to look at the things I talked about at the start, which is starting the game and basically the game behaviors that make it work. And this is where we have to talk about state, because, and again, you should think about this up front because it's kind of important. when the game is being used, it'll be in, well, in my case, one of two different states, starting the game and playing the game. You might have a third state which is showing the high score. That's fine, and the design I'm going to show you makes it really easy to add that. Okay, but if you look at the way I've done this, this is my update method. XNA calls that and says, okay, time for you to update. I have a variable called state which has two possible values, start screen and playing game. And if I call update and I'm in the start screen state, I'll call update start screen. If I'm in the game and I call update and I'm in the playing game state, I'll call update gameplay. First is, you may not have seen switches yet, but a switch is basically a way in which I can pick a behavior based on the value of a particular variable. So this thing here has got two possible values. If I wanted to have a high score table, I'd make a game state called showing high score and then have an update in there for showing high score. Does that make sense? So this is just me being aware of the fact. Hello, a question? Yes?
When would you use switches instead of if statements? Like, is there...
The thing about the question is, when would I use a switch rather than an if? The answer is really when I want to make my life easier. Because with a switch, I can just put another case in here and keep adding them. With an if, I have to have lots and lots of ifs. The answer to the question is, you could just use ifs. It doesn't really matter. Switches or ifs will give you the same behavior. It's just that switches fit better on a slide, if that helps. And they're actually a better way to do it. So I tend to use switches in this situation. I could add 3 or 4 more game states, just pop them in as cases in there. It'd be easy to do. Whereas more if statements would be a bit more tedious. You don't need switch, I just quite like using it. Does that make sense? Yep, okay. I'll stop asking. This is the start screen update method. And this is the method which is called when the game is waiting for the user to start it. And in that situation, I only care about one thing. I want the space bar to be pressed. So what this code does here is it goes up to the keyboard and says, okay, tell me what keys you've got. And then the keyboard comes back and says, okay, I can ask you, is the space key pressed down? And if it is, start playing the game, please. So this is the code that basically gets the game going. And it doesn't do anything else. If I wanted to have an animated start screen that had things moving around and lights flashing and whatnot and all that kind of good stuff, I could put that code in here as well, but mine doesn't do that. Does that make sense? So if I wanted to have like a piece of fake gameplay running, you often see in the attract mode, most games have got something happening on the screen. Mine doesn't have that, but yours quite easily could do. And the place you put the code is there. This, if I go keys.blah, I can look for any kind of key. And that includes left shift, right shift, control, alt, all those keys as well. So you can look at control keys as well as the actual printing ones. So you can do 2-player games by having different shift keys each side of the keyboard. That also works quite well. And also bear in mind that these are checking to see if the key is up or down. They're not checking to see whether it's actually just been pressed. Okay, so you poll the keyboard. For example, in a pinball game, you want buttons that control the flippers, and when they're held down, the flipper should be up. When you release it, the flipper goes down. Very easy to do, because you can just check the keys down each time around the update loop. Does that make sense? So that's how you do it, and you'll see that code again a bit further down when we're playing the game. So, start playing game. Well, what does that do? Well, first thing it does, it says to all the sprites, hey, it's a brand new game, reset yourselves. So all the sprites go through and set themselves up and put themselves back where they should be. Then I set my timer, which is my game timer, and my score. And I'm not particularly proud of these bits of code. Let's go through them one at a time, though. This one I quite like. Spin through all the sprites and reset them. That's perfectly fine. That's what you should do. And that's telling each sprite, hey, it's time to reset yourself. And that'll cause the cheese to go back to the middle of the screen. And it'll cause all the moving things to stop. And if a thing has 3 lives before you kill it, that's where you put the 3 lives back to 3 again, or 0 or whatever. You see what I'm saying? You have to have a way of taking your game object and saying, hey, you're back at the end of the game now, reset yourself. And so you put that in. Timer, XNA, remember I said it calls update, it does it 60 times a second. So if I count 600 updates, that means I've had 10 seconds go by, correct? Now, again, I'm not proud of this because I should really have in there a thing which acknowledges the frame rate. Because if you run XNA on other platforms, like on the phone, it might go at 30 Hertz. XNA on the phone tends to run at 30 Hertz because you flatten the battery faster and the screen's a bit smaller. So you can run things at a lower speed, which saves battery power, and the screen res is a bit lower, and the size of it, you don't see flickering quite so much, so they go a bit slower. But as far as I'm concerned, for now that works, and that says I've got 600 clicks before the game ends, which is 10 seconds, and of course I haven't scored anything yet, so my score is set to 0. And then what I do, because the game is starting, I flip my state to, hey, we're now playing the game. If you've not seen enums before, then these are just types that I can create of my own that have a range of values that I've invented. We know that integer has numbers, bool has true and false. This variable has two possible states, playing game and start. Does that make sense? We all kind of okay? Have I lost the audience yet? So when they press the button, to go back to the story, I'm updating my game at the start screen. The user presses the space button to start the game off. This update method notices that and calls start playing game. At that point, we reset all the sprites, put them back on the screen. We set the timer so the game will run for 10 seconds, clear the score, and then flip into the other state. So next time update's called, it'll call the game update behavior instead. This is how games work. It's kind of cute. And now we have the big meaty part in the middle of this presentation, which is the gripping bit. What happens when you update the game? Well, here we go. I get my update gameplay method, I go off and read the keyboard, and anything which can move, I can tell it to start moving or stop moving. So I'm going to send a message to my game object to say, hey, you start moving this way or stop moving that way. And if they press the up key, then cheese, start moving up. If they don't press the up key, don't move up. Does that make sense? I've got three others for left and right and down. So effectively there's 8 different messages I can send the cheese. The cheese can be told to go up, down, left or right, or stop doing those things, okay? And the cheese will remember, because the cheese always remembers where it's going, okay? So I tend to start moving, and then when I update the cheese, I say, okay, Mr. Cheese, update yourself. It'll go, okay, now I know I'm going up, so I'll move up. And that's how we get the cheese to work. And, yep.
If I want to add a jumping mechanism in there,
Yep.
would I have, I'd obviously have to press spacebar for the jump button.
Yep.
Would I have to set the constant gravity to 9.8 so it would come down?
Yes. I can show you how to do that with my physics-based mover, if you like. We'll see if we can fix that. I'll show you what happens. It's actually kind of cute. The question is to do with how can I make things jump up in the air. You want to apply an impulse. You want to give it a kick so it goes up and then comes down. And there's a much neater way of doing it than what you've described, which we'll come to. But that's a really good. Hold that one. Don't let me escape. Actually, that's a really good one. I'll share because I think I can do that. Okay, so back to the plot. I get the cheese moving. I ask each sprite in the game to update itself. I say, okay, a 60th of a second has passed since you were last updated, so move a distance appropriate to that, depending on what your speed is. And so I update each of my sprites. If, again, not happy with this, if the speed changes, that fraction has to change. Even less happy with the fact I work that sum out every time. How inefficient is that? I could make it a constant. I could call it frame rate or frame time or whatever, but I haven't done. I wrote this about 11:30, so it's not been... yeah, okay, so that's done, right? You okay with that? That's saying, okay, guys, move yourselves. And then I spin through all the targets, and here's the thing which is interesting. My for each loop goes to a list of all my crackers. At the moment I only have one, but that could change. And intersects with is a method exposed by sprites that says I can check to see if these two sprites are doing that. Because if they are, that means that one of them has crashed into the other one, correct? So my sprite, and you could just use this, exposes an intersects with method that effectively says, okay, you guys have clashed. If the cheese has hit the cracker, play the burp sound, put the cracker randomly on the screen somewhere else, give myself 10 points. So there's no particular magic here. This is just C# code. So if I've hit the cheese, play the sound effect, put the cracker back on the screen somewhere else, put the score up. Sound effects are basically WAV files you can load in, and the load content method has done that for me. I'll show you that code a little bit later as well. A lot of things to show you a little bit later. Then what we do is we go, okay, make the timer one smaller, get a number of seconds left by dividing it by 60, and put this in a message string which the user will see, which says how much time you've got left and what score you've got. And that's drawn by the system when it draws the screen each time. And if the timer has hit 0, game over. So my game over method then just shuts everything down and flips back into the game over state. So that's how my program actually sort of runs. Does that make sense? Yep, question, sorry?
Why are you using integer for the time left? Wouldn't it make more use to use double since you're dividing?
There.
Yeah.
The question is, why am I using integer for that? The answer is because I want to show how many. I want to show 10, 9, 8, 7, 6, 5, 4. I could show 10.5, blah, 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 but it would look a bit weird. So I'm just counting down in seconds. So I'm deliberately doing an integer division there, so I can get a counter which changes once a second. That's just me. Okay, so if the game ends, we go to game over. And this is the final bit I'll show you before we dive into the code. This is the bit that draws the game world. And it goes through each of the sprites and asks it to draw itself. Then it works out the exposition of my message by finding out how long it is and then centering it based on the length of the string and the screen width. And then it just draws this message string. And these guys here, sprite batch, are the way that XNA batches up drawing operations for the graphics card. So we'll put all our drawing inside here so that when it hits the end, it knows that's the point at which you have to get all the textures, all the bits and pieces, shuffle them all up, and push them over into the graphics card in one big push. So this is the way in which game engines tend to work is to batch things up using this kind of approach, and that's how it does it. Okay, so that's draw the sprites. Sprites themselves, here's how a sprite draws itself. It says, let's get the X position, round it up, convert it into an integer, and slap it in the rectangle. Let's do the same for the Y, round it up, put it in Y, the rectangle, and then special version of sprite batch that says, draw this texture in this rectangle using a white light. Now, you can have fun with the color. I haven't done it for my sprites, but you could have a draw color as well. So if you want to show things heating up, you could draw them using a red light as opposed to the white one, or cooling down, use blue. So if you want to show the status of things in a really easy, quick way, then draw them with different colors. In fact, one trick I used in one game was I wanted lots of different colored objects, so I made everything grey and then changed the color of the light on it, and that worked really well. And so it also, if you shine green light on red things, they appear black because that's how colors work. So you can do all kinds of funky things with that. But that's effectively how I draw things. And what I'll do now is I'll dive into the code and we'll spend 10 minutes just looking through what it does and playing with it. So this is what I've shown you. This is my basic sprite. Here he is. And if you look at what he will do, he can that's set position, that places him on the screen at X and Y. That's the constructor. Let's keep on going down here. I can draw him. The update method in the standard sprite does nothing, but that might change in other sprites. The reset position puts you back where you should be. Well, I spelled that wrong. Reset position. Okay, spell it right. Isn't refactoring wonderful? I-O-N. Yeah, do that. So reset puts him back. Get center says, tell me whereabouts the middle of the sprite is so I can do calculations with that. And it basically figures out where you are, adds half the width, and then figures out where you are, adds half the height, and it makes a vector, which is those two things. Once I've got that, I can use a thing called getDistanceFrom, which will tell me how far apart two sprites are. So if you've got a thing where you're sneaking up to somebody, well, now I'm thinking about Metal Gear Solid type gameplay. You have to sneak past. If you get too close to the guy, he wakes up and comes after you. That's how you do that. You just check this distance value. As soon as it gets below a certain tolerance value, that's when he wakes up and chases you. Does that make sense? So that's very useful for that. Moving down here, there's get center, get distance from, and there's my friend intersects with, which basically says, does my rectangle intersect with your rectangle? Because that's kind of built into the way the framework works. So that's my standard sprite. That's my target. Mover's kind of funky, because what mover does is there's start moving up, start moving down, stop, which is really tedious to write, but it's quite useful to do it this way. And then they've got these. These are on my internal flags to say which way you're going. That's the speed it's moving at when you reset it. That's the speed it has when you are using it. Reset puts everything back so that it's effectively not moving anymore, and the speed is at the reset speed. This guy sets the speed. Update's kind of weird, because update says take the position, add the speed times the change in time, and that's your new position. This is Newton. S equals ut plus a half at squared kind of rubbish. Now what this is doing is saying I'm going at so much speed, I've been going for so long, therefore my position has been changed by that distance. And so these guys work out, if I'm moving right, we basically, moving left makes me go that way because the position goes that way, moving right I go that way, and then up and down, if I'm moving up, then y has to get smaller, and if I'm moving down, y has to get bigger. You don't have to change this code, I'm just showing you how it works. And then what Robert does is a technique called clamping. And what clamping does is it says, okay, I'm not going to let you move off the screen. If you go off the X end, I'll force you back to 0. So if you try and push off the X end, I'll knock you back to 0. Try and push off the right end, which is the width of the position plus the width of the object. If that has to get bigger than the screen width, we pull you back and clamp you to the side as well. So these two little bits of code here make sure I can't move the cheese off the screen. And so if I run the program, you'll see that in action. Because if I try and do it, then press space, off we go, bang, won't let me. It gets stuck when I hit the end, it just won't let go any further. If I go back up and I get the cheese and play the burp, and then off we go, it's another one, and so on. Not really good design, the colours are hard to see. Oh, 20, 30, that's not really good, 30 points is. It gets quite compulsive after a while, but it's not that gripping really. Take a look at Physics Mover, because Physics Mover is really fun. Physics Mover behaves like a thing with proper acceleration using physics. Except that all I've done is I've cheated like crazy, okay? Because in games, that's what you do. You cheat much you can. The Physics Mover, look at his update method. I take the acceleration times the time, and I add it to the speed now, not to the position. Because if you're in a car and you press the accelerator down, that means you'll actually change your speed, you see. And so this is saying multiply those up together, add to the speed, and then when you've done that, use the speed to move the... Oh, wrong mouse. Use the speed to move the object around. And I also do some things, I do some thresholding, and I have a thing called friction. And what friction does is it slows you down. Because if otherwise you just keep on going faster and faster and faster until you crash. And friction is the value between 0 and 1 that gives you how sticky the thing is. If it's 1, that means it's basically you're on ice. If it's 0.9, you will slow down. We can play with these numbers. See what I can do, because this is kind of funky. I can go into my game, make it a bit bigger so you can see it. My load content method does the loading, and inside here I've got, I can make cheese is either a mover, what you've seen, which is the mover with 500 pixels, or I can actually make him into a physics mover, which is where I just do that and do that. And so now he's a new type of sprite, and now I give him the acceleration, there it is, 500 seems to work, and a friction of 0.999. Run the program now, and the cheese behaves quite differently. So if I hold the button, oh go on, move. Hold the button down, it speeds up and slows down, and it bounces off the edges too. I've made it sort of bouncy, so now whoa, I can make it go in curves and all kinds of stuff. That's effectively a bit more interesting, because now I've got like physics control. If you want to, what you can do I might not have time to do it now, but I'll certainly have a go at doing it afterwards. You could make a version of Physics Mover which effectively knows about gravity. So rather than just friction, which is slowing you down, gravity is pulling you down all the time. Okay? So you can effectively have an impulse that moves your speed up that way. So when you hit that, you get shot up in the air a bit, and then gravity pulls you down again. And that's how jumping would be made to work. Does that kind of make sense? But it's all done by cheating. And the other thing which I'll show you, which is kind of cute, which makes it a bit more interesting too, if I go into here, those are my sprites. Go into the game, and we'll find that what I've done is I have a list of crackers, and if I want to make the game kind of more weird, say I want 100 of these things, just make 100 of them in a for loop. So now what I'm doing is I'm making 100 targets, adding them to the list and to the sprites on the screen. So now if I run it and I press that, I've got more sprites to go at now. Yeah, okay, that's much better. I'm happy with that score. That's much more like it. And you can also do other things, because you see what's happening in my game in the update method. Where are we? This stuff here starts the cheese moving depending on which button has been pressed. Okay. Now, I could have crackers, which are stationary targets that you can go after. I could also have killers, and a killer could have an update behavior, which basically is driven from the game and says, if this guy is to the left of you, start moving to the right, and if he's above you, start moving down, and that gives you a nice chase behavior. So if you want to add that, that's really easy to do. I haven't got time to do it now, unfortunately, but what I'll do is I'll pop that in. I'll add more different types of sprite as the week goes by, but the fundamental way in which it works is basically you just take these objects, map new textures onto them, and run with them. Does that kind of make sense? There's one piece of how-to which you'll need, which I'll also put online. I'll put a link to a presentation that covers that. When you make your sprites, you see here, if we look on my game, then what I have is a folder called Content. And Content contains all my sprites, the cheese and the explode sound and the burp and bits and pieces that I'm going to use on tablecloth. You basically make a folder called Content, and you drag things into there and then pick them up by name. Now, for PNG files, this works a treat. For sound files, there's a conversion process you have to go through that makes them work with XNA, which involves making a XNA4 project, which then produces a file you can work with. But I'll record a little webcast that shows how to do that, and I'll put that on 3thinggame.com. I'll do that tonight as well. Okay? So I'll put this up. I'll hopefully have a recording which you can watch through as well, and I'll put this sample code up as well. Was that useful? Are you less scared or more scared? Little less. Again. Okay, so thank you very much. That's about the right time, so we'll call a halt there.